Today we are going to relate congruent and similar figures using our geometric transformations from last chapter. So on this first example it says consider triangle P, Q, R, and S under the following transformations. P is translated 6 units to the right and 2 units down for triangle Q. P is reflected in the x-axis, so over the x-axis, to form triangle R. P is then rotated 90 degrees clockwise about the origin to form triangle S. The question is the following. What do you notice about the shape and size of all of the triangles? All of the triangles have the same shape and size. So if you do a translation, a reflection, or a rotation, you still get congruent figures. The question then asks, do dilations result in a congruent image, and explain? Well, normally a dilation either gets bigger or smaller, so that means they are not the same size. They are always, though, the same shape. So if they remain the same shape, normally dilations give you similar figures. There are 2 exceptions to the rules. If you have a dilation with a scale factor of 1 or -1, remember that keeps both the same shape and same size, so in those 2 special cases you would end up with congruent figures. Other than that, they are always only similar shapes. Okay, so if we look at this first one, it says triangles U and V are congruent triangles. Describe a transformation that maps triangle U onto triangle V. So we're just using our information from last chapter. If I look here, it looks to me that I can find a line of reflection. Right here, if I were to fold this paper right there, my points would lie one on top of the other. So this then would be a reflection. And remember from last chapter, when we talk about a reflection, you have to put what it was reflected over. And we drew our line in here. And every time I do that, it moves it. Apologize. There we go. That line intersects my y-axis at 1. So the equation would be over the y equals 1 line. Our next example then is the following. Josh is looking at a photo OABC on his computer screen and wants to enlarge it to the size of OA'B'C' for a newsletter. Explain why the geometric transformation that resulted in a similar rectangular picture is a dilation instead of the other 3. It's a dilation because the figures are similar. So anytime that you have something that ends up with similar figures, it's going to be, the only option is a dilation. Number 2 then, it says what is the scale factor of the dilation and what is the center of dilation, and this is from last chapter. Remember, when you want to find the center of dilation, you draw your lines in and you connect them to the corresponding one and see where all of these lines intersect. I'm going to connect A prime to A, C prime to C. All of my lines, when I connect them, intersect at 0, 0 if I don't bounce it off. If I look here, hold on, let me bounce it back. There we go. They intersect at 0, 0. Whatever then, when I pick my pen up, it scoops it over a little bit. So my center then is at 0, 0. My scale factor, if I look here, this side was 1, 2, 3 in the original. In the new one, it's 1, 2, 3, 4, and that looks like 4.5. So in my new one, it's 4.5. So to find my scale factor, it is the image over the original, so 4.5 over 3 would be my scale factor. if you change 4.5 over 3, that would be the same as 3 over 2. I probably would have been better off if I would have used the other sides, because now if I notice, this side going up is 2, the other side is 3, and that would automatically give me 3 over 2, and I wouldn't have had to guess at this being 4.5. Our next one then is talking about a snowball. It says a snowball of diameter of 3 inches rolled down a slope to become a similar snowball of diameter of 3 feet. Explain why the geometric transformation that resulted in a similar snowball is a dilation. It's a dilation because it had the same shape but different size. Because obviously when it rolls down the hill it picks up more snow and it gets bigger. If it would have rolled down it like a rock and stayed the same size, it wouldn't have been a dilation because it would have been congruent figures, so it would have been a translation. It just rolled down. The next question says, what is the scale factor of the dilation? Well, remember to figure out scale factor, you put the image, which would be 3 feet, over the original started as 3 inches. The problem here is this. If you notice your units, we've always said to pay attention to those units. Our units are not the same, so we need to change them to be the same. So in order to get that, I know there's 12 inches in each foot, so I'm going to take the numerator times 12 to change that to inches. That would give me 36 inches over 3 inches. Now that my units are the same, my units cancel out. I'm left with 36 over 3, which reduces to 12. So my scale factor is 12. It makes sense that it is greater than 1 because the snowball as it rolled down the hill got larger. Your guided practice for this section is page 145, number 1, and 147, 2 and 3. Your assignment is page 154 through 156, 1 through 5, and 7 through 8.